All right, a very natural idea. Now, how well does it work? Well, it turns out that it's going to stop a lot of the basic attacks we've shown you so far. But it's possible attackers can adapt to this. It's often possible to defeat this defense if you know this defense is in use. So if we just deployed this defense, then over time attackers would discover, oh, everybody's using dep, so I'm going to modify my exploits to bypass it. And a standard way to bypass it is an attack called return into libc. And this is kind of a cute, neat, clever idea that works by not introducing any new malicious code into memory, but still taking control of the program. And it's going to do that by, instead of introducing new malicious code that the attacker came up with, it's going to use existing code that's already in memory. And it's going to, in particular, find some library function that's already existing and find a way to transfer control to that library function. And if we can find a library function, if we, the attacker, can find a library function that does the bad stuff we as an attacker want to accomplish, then we don't actually need to get new code into memory. We can reuse the existing library code. And there's one that's particularly handy that's typically used, which is the library function exec, which what it does is it runs some new code. It replaces the current code of your process with the code of some other binary on disk. Okay? And there's multiple of these kinds of library functions. Another one would be the system library function, which executes a shell command. Okay, so then we're not replacing any of the existing code. We're just running existing code to execute some command line shell command. Now, for this to be useful to an attacker, they're going to have to control the arguments to that library function. So the return into libc attack involves modifying the call stack, overwriting the call stack, to replace part of the call stack with what looks like a fake stack frame containing arguments for this library function, and then transferring control to the start of that library function. And we're not going to call it, we're just going to kind of like jump to the start of that library function. And that library function is then going to look at the stack for its arguments. And so if we've put the right stuff in the right spot on the stack, then it will use whatever we put there as arguments. Okay, so that's the clever idea of the return into libc attack. And I'll try to illustrate this with a picture. Let's say that we've got, this is the stack frame of the currently running function. It's some piece in the application that's got a buffer overrun. And let's say it's got a stack allocated buffer here, one of the local variables that's overflowable. So the attacker can overwrite that and overwrite past the end and start overwriting stuff on the stack. Here's what the attacker can do. They can do an overwrite like this, and overwrite the original stuff with this red stuff. So going to overwrite, well, in particular, we're going to overwrite the return address of the current function, and they're going to overwrite the stuff above that. And above that, we're going to put a fake stack frame. When this function returns, what is it going to do? It's going to do its epilogue stuff. So start popping off stuff, popping off this part of the stack. It's going to go restore the frame pointer from this part. And then it's going to find the return address, and it's going to pop that off and transfer control to whatever address was there. The attacker has put in the address, instead of the original return address, has put the address of the start of the exec function. So the CPU is going to transfer control over to the start of the exec function. It's going to change the save frame pointer to something that the attacker chose, and it's going to start executing at the beginning of the exec function. And that exec function has no idea. It wasn't like called normally, that it's being started to run in this irregular way. And now the stack pointer will have popped off all that stuff at the bottom, and it will look just like this. The red stuff with the stack pointer kind of pointing here, and now the function, the code inside the exec function starts running. And so from that code's perspective, it looks like it was just called and someone saved the return address, and then above that were arguments. And so when it runs, it's going to go use that stuff, and it's going to look up there in that red area for arguments. And so we could fill in whatever pointers we want to whatever arguments we want, and then it will run with the arguments we chose. So in this way, the attacker invokes one library function with arguments of the attacker's choosing, and that runs. Okay, so if that shell command, if we caused it to launch a shell command and the shell command was like erase all files on your disk, you're in trouble. Or if it was like connect to this server, download a program and run it, you're in trouble. Okay, so this exploit actually allows you to bypass dep. But the one limitation of return into libc is that the attacker can only call a single library function. Because when the exec library function finishes executing, it's going to like try to return to that return address, but the call stack up above there has been kind of messed up, and so the next thing that runs will kind of get a messed up call stack. And we can't really control what's going to, we kind of lose control of what's happening after that, and so you kind of get one. You get one for free. All right. So this non-executable pages on its own is not enough for defense.